Hey everyone, notes 5.3 are on the length of a line segment. And I just want to show you something really quickly. Don't graph anything out right now, but I just want to show you what would happen if I had a point right here and another point right here, and I have this line segment. Again, don't graph this out on your paper. And I want to figure out how big this is. So I can count this as 1, 2, 3, 4, 5. I can see that this segment is 5 units long, okay? Assuming that each one of these is 1, which we will label to show that each one of these is in fact 1 unit, okay? And then same thing would be true if I wanted to do a vertical line. So if I went from here to here, for example, this line segment right here has a length of 1, 2, 3, 4, 5, 6, 7 units. So when it's vertical or horizontal, it's really easy to figure out how big these lengths are or how big these line segments are. But let's say I wanted to figure out how large this line segment is right here. I would not be able to figure this out just by counting because this right here, I don't know exactly how many units this is going to be. So we have to find a different way to do this. So how do we do this? Well, if you remember Pythagorean Theorem, says in a right angle triangle, the length of the hypotenuse squared is equal to the sum of the lengths of the other two sides or the legs squared. Huh? What does this mean? All this is saying is a squared plus b squared equals c squared, where a and b are the legs and then c is the hypotenuse. How do I know C is the hypotenuse? Because it's across from the right angle. And then A and B are legs. Okay? How is this going to be useful? Let's take a look at what we have here. So it says, what is the distance between the point A, 2, 5, and the point B, 6, 2? So I'm going to go to 2, 5, and I'm going to label this A. And then I'm going to go to 6, 2, and I'm going to label this B. And I want to know how big this length is right here. How is Pythagorean theorem going to help me? We're going to add a point C. And that point C is going to give me a right triangle. So if you look right here, I can add this point C right here. And now I have a right triangle with vertical and horizontal segments that I can actually count how big they are. So this means that C right here is at the point 2, 2. And I guess I should say, in case we didn't realize, I'm very sorry, but I do want you to graph this stuff out now, okay? So the next thing I need to do is find the distance from A to C. So I want to know how big it is from A to C. So when I zoom in on this, I can see it went down by 3. So the distance from A to C is 3. And then I also want to know the distance from C to B. So if I were to zoom in on this right here from C to B, this went over by 4. So the distance from C to B is 4. And then I want to find out what AB is. So this right here is my unknown. If I don't know it, I'll call it X, or I can call it C. So when I plug this in right here, this says to do AC squared, which is this side length right here. And then, so this would be 3 squared. Plus, then it says to do BC squared, which is this side length right here, which is 4. And that's going to equal this side length right here that I'm trying to figure out right here. So that's going to equal X squared. Okay, this is like A squared plus B squared is equal to C squared. That's all we're doing right here. So 3 squared is 9. 4 squared is 16. And x squared is just still x squared. So here I can say, I can add the 9 and the 16 together. I get 25. So I get 25 is equal to x squared. And then I can square root both sides. And I get x equals 5. So therefore, AB, the segment AB, has a length of 5. So we can derive a general formula using the exact same method right here. So I need to figure out, my goal is to find the distance from P1 to P2, point 1 to point 2. And this point 1 right here, I'm going to call this point 1 x1, y1. Okay? And I'm going to call this point 2 x2, y2. So let's talk about this for a second, because if you take a look up here, point A was 2, 5. So I'm going to write down 2, 5 next to it so you can see what I'm talking about. And point B was 6, 2. And if you notice here, the distance from A to C was 3 because it went down by 3 right here. So this distance here is already 3. But if you notice, where did that 3 come from? It came from taking my two y values and subtracting them. So to find this 3 right here, I really just did 5 minus 2. So to find this corresponding value right here, I would just figure out the difference in my y value. So if you notice right here, this y value is at y2, and that this y value, is at y1. So to find the distance between my two y values, I'm just going to do y2 minus y1. Okay? And then I'm going to do something similar. Just going to put this up here. I'm going to do something similar with my x values. So if you notice right here, let's look back up here. How did we get this 4? Well, we took the 6 right here and we subtracted the 2 from it. So 6 minus 2 gave us that 4. So here I'm going to take my x value, which is x2, and then I'm going to subtract my other x value, which is x1, and that tells me that this whole distance right here is x2 minus x1. And I'm trying to figure out this length right here. This is what I want to know. So just like we always do, we are going to do a squared plus b squared is equal to c squared, okay? But I need to fill in this information right here. So we know that the c is the hypotenuse. It's this side right here. So we're going to find L squared right here. And then the a is this side length. It doesn't really matter. So I'll just say the a is this side length. I could also say it's the vertical side length. It doesn't matter. So I can say it's x2 minus x1 squared. That's the a value, plus now the b value will be this vertical piece right here. So this is y2 minus y1 squared. But I don't want to know what L squared is. I want to know what L is. So I'm going to square root both sides. And now I can say that L is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that, my friends, is the distance formula. Now I know that this looks scary, but it's just like the quadratic formula. It looks scarier than it actually is. So let's apply this to our first example. So it says, what is the distance from the origin to the point -1, -4? So just a reminder, the origin is 0, 0. So when I take a look at this right here, one of my points is at 0, 0, and then the other point is at -1, -4. So here's my other point right here. And I want to calculate this distance right here. So I could draw in my right triangle and do it that way, or I could use the distance formula. So I know right here that 0 is x1, and I know that -1 is x2. And I also know here that this 0 is y1, and this -4 is y2. I'm going to repeatedly write this formula down over and over and over again until it gets stuck in my head. Don't forget the square root has to go over this entire thing. And I'm literally just going to fill in all of the numbers that I have here. Okay, so right here, I'm going to fill in, instead of x2, I'm going to replace it with this -1. So I'm going to say -1, and then here x1 is 0, so -1 minus 0. For y2, I would say -4 minus y1, which is also 0. And then inside my brackets, underneath my square root, I'm going to evaluate each set of brackets. So -1 minus 0 is -1. Do not forget to put that in brackets. It's really important that you put that in brackets, especially if it's a negative value. And then -4 minus 0 is -4. I'm going to square that. So here I get the square root of -1 squared, which is 1. Plus -4 squared, which is 16. So right here, my final answer would be the length is the square root of 17. Okay, and that's my final answer. I'm leaving it this way because I can't square root 17 evenly. I get an irrational number. I want an exact answer. Now, if you like, you can always go through and just draw in your right triangle right here. So we can say here that this is 4 and that this is 1. So we would do 4 squared plus 1 squared equals x squared, which is exactly what we have right here. Okay? All right, so question number 2, find the length of the line segments with the following endpoints. So right here, first thing I'm going to do is identify what's what. So this right here is x1, this right here is x2, this right here is y1, and this right here is y2. And we know the formula is L equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's go ahead and fill in that information right here. So x2 is negative 3, and then I'm going to subtract x1, which is also negative 3, and the minus and negative becomes a plus. Okay, and then in the other set of brackets right here, I'm going to take y2, which is 2, and then I'm going to subtract y1, which is 0. Okay, so I'm going to go ahead and evaluate these numbers right here. So negative 3 plus 3 is 0. So I end up getting 0 squared plus, I'm just going to move this down right here. 2 minus 0 right here gives me 2. So 0 squared is just 0. I don't even have to bother writing it down. 2 squared is 4. 0 plus 4 is 4. So our length here would be equal to 2. Okay, I'm going to have you pause, try this one on your own, and then double check to see if you get the same answer as me. Okay, so don't press play until you try this on your own. So this is the answer that you should have gotten. If you did not get this answer, go through, look at your work maybe once or 2 more times. And if you're still struggling with it, just write a note to have me look at it in class so we can help you figure out what might have gone wrong. Okay? All right, people, in our last example, it says to determine the length of a median from vertex A of a triangle whose vertices are as follows. So let's start by graphing out triangle ABC. So A is at negative 2, 6, B is at 5, negative 3, and C is at negative 7, negative 7. So this is A, this is B, this is C. Notice how I haven't labeled the vertices until after I've gotten my graph because I want to make sure that it's not going to be in the middle of my triangle. And then I want to find the length of the median from vertex A, which means that I'm going to draw in my median from A to the midpoint of BC. So the first thing I need to do is find the midpoint of BC. So to find that, the formula is x1 plus x2 over 2, and then y1 plus y2 over 2. So here, in this example, x1 is 5, x2 is negative 7, y1 is negative 3, y2 is negative 7. So go ahead and fill in that information right here. So when I do that right here, I should have 5 plus negative 7, and then divided by 2. And then on the other side, I've got negative 3 plus negative 7 divided by 2. So my midpoint is going to be negative 2 over 2, negative 10 over 2, which means that my midpoint would be negative 1, negative 5. Let's make sure that negative 1, negative 5 makes sense for my midpoint, and it sure does. Now I want to calculate the distance from A to M. So to find this distance right here, step 1 was to find the midpoint. To find the distance, I need to use the distance formula. So it's telling us that the length is x2 minus x1 squared plus y2 minus y1 squared. And I need to use the points A, which is negative 2, 6, and M, which is negative 1, negative 5. And I'm just going to plug in that information here. So L is equal to the square root of x2 here. So here this is x1, this is x2, this is y1, this is y2. So x2 would be -1. X1 is -2, so it's minus -2, so it's plus 2 quantity squared. And then y2 is -5, and I'm going to subtract 6 from that. So I would do -5 minus 6 squared. So here I'm going to evaluate each piece. So -1 plus 2 is +1. -5 minus 6 is -11. So then here, when I do this, I end up getting 1 plus 121. So the length here is the square root of 122. And I'm going to actually figure out approximately how big this is going to be. So I'm going to type in the square root of 122, and I'm going to get approximately 11.05. So we can say, therefore, the median from A is approximately 11.05 units. And that's it for this video. Let me know if you have any questions, and I'll see you in class. Bye.